Hi, my name is Alex Rockwell, and this is my Module 1 practice response. So I took a little bit of a different approach to this project. I did not actually physically complete my STEM challenge. That's what we call them at my school. But I did design one, and I'm going to talk a little bit about it. And I actually am on the science curriculum mapping committee for my 4th grade science department, along with one other teacher. And I contacted him, and we are actually going to implement this exact activity this school year. So I'm excited, and I think that the students are going to absolutely love it. So while I didn't complete the actual STEM challenge that I'm going to show you, I did create the thermometers, and I did watch them over the period of an hour and a half, as you can see here. And I was actually surprised, as you can see, my white bottle seemed to have more hot air than the black bottle. But when I picked them both up at 12, which was when I was most surprised when I walked outside, the black bottle was definitely hotter, so I don't know if there was something wrong with that balloon. There's tons of variables that could have happened there, but I was surprised with that. So I can always use these pictures to show my students how to create these thermometers and the purpose and what's going to happen with them. So my actual challenge has to do with the different locations at my school. So here I have an aerial view of my school, and we are split into 3 communities. So this is the yellow community, the red community, and the blue community, and each community has 2 floors that has grades 4, 5, and 6 in it. And each community has their own playground. As you can see, I've labeled the yellow playground here, the red playground, and the blue playground. So I teach in the yellow community, and our students are always asking, what's the red playground like? What's the blue playground like? So my question that I am having the students investigate is, which playground is the hottest? So that would be something that I think my students would love. They would, it would be relevant to their lives. I mean, they're always asking us, what do the playgrounds look like? So not only would they be able to actually get to see all of the playgrounds, they would be able to compare some things about them. So which playground is the hottest? So for the design process, the engineering design process, my problem is which playground is the hottest, red, yellow, or blue? So then explore, we'd have to discuss, where are we going to put our thermometers? How are we going to measure these? How are we going to tell which ones will be the hottest? So there are a lot of things that we would have to come up with as a class of how are we going to do this? And then they're going to obviously create those thermometers, so they'll need to be enough for each playground. And then we could put them on each playground, and after a certain period of time, go out to each one, compare the pictures of the balloons to see which balloons were most inflated versus which ones were not. And then after that, how can we adjust anything? Should we make more bottles? Should we use different colors? Should we put them in a different location on each playground? So there's lots of things that we can do to make this a little bit better, to answer our original question of which playground is the hottest. So using the STEM practices chart here, you can see I've circled what I think applies to this challenge. Obviously there's going to be a lot of questions. I am asking the original question, which playground is the hottest? And the students are constructing explanations. You know, the red playground is the hottest because, the blue playground is the hottest because. So they will have to use those tools in order to answer that question. Engineering, they're obviously first going to have to engineer and create those thermometers, and then they're also going to have to interpret their data. So taking those pictures is great, but it's, what did you do with those pictures? What are you learning from those pictures? How does that help you answer your question? And then in red there, I had in the technology column, I circled learn how to use new technologies as they become available. And I think that one of the biggest misconceptions about technology is that it's something that you have to plug in, but it's not. Technology is just a tool that you use. So in this case, our technology are those bottles that we are using. It's our thermometers. No, you don't have to plug it in. No, it's not battery powered. But that is our technology. So it's learning how to use that as it becomes available. And then finally, in the math, they are going to have to reason abstractly and quantitatively. So they're going to have to think, why is it hotter? Once we figure out that one is hotter than the others, why? Answering that question or thinking about why is that the case? At the end of all of our STEAM challenges that we do, there's always a section that says further inquiries. And we have the students come up with usually 3 to 5 questions that if we could do this again, what else would you want to know? Or are there any other questions that you still have? So this is one of my favorite parts about doing STEM challenges in my science classes, because the things that they come up with are sometimes things that I never even would have come up with. We currently do a similar lab where we take actual thermometers out and we tape one on a black piece of paper, one on a white piece of paper, and one on the concrete, and then compare the difference in temperature on the 3 surfaces. And these are some of the questions that I think that, based on what I get from that the students would come up with from this STEM challenge. So I think that they would always, ask how much hotter is the hottest playground. They'd want to know exactly how much. They also might want to experiment, is there a difference between first and third recess? Right now, 4th grade goes out for the first recess. How much hotter would it be if we went out for the third recess? Is a different playground hotter during third recess? Which classroom on team is the hottest? What time of day is it the hottest? And is the blacktop hotter than the kickball field? Things like that. So I think that those are the most powerful parts of the STEM challenges, because it truly shows that it gets their gears turning and they're thinking, oh my goodness, now I want to experiment to do this, I want to do this, and I want to do this. And that's the goal of these STEM challenges, is to create that love of learning and those problem solvers. So thank you. Let me know if you have any questions in the comments.